Before stars were born, before galaxies spun, before there was even a single point of light in the night sky, there was only darkness. The kind of darkness that is absolute. Not the darkness of a moonless night or a shadowed cave, but the darkness of nothingness. The absence not just of light, but of form, structure, and color. A darkness that had never been broken. And yet, even in this emptiness, the universe existed. It had been born in a burst of energy, the Big Bang, a moment when space and time themselves came into being. In an instant, the cosmos erupted from a point smaller than an atom and began expanding in all directions. In its first fractions of a second, the universe was a seething, incomprehensible plasma of pure energy. Temperatures were trillions of degrees. Particles blinked in and out of existence. Forces, gravity, electromagnetism, and the nuclear interactions began to take shape. Matter, energy, time, and space all began their journey together. As the universe expanded, it cooled. Within the first 3 minutes, it became cool enough for the formation of the first atomic nuclei, mostly hydrogen, with a little helium and a trace of lithium. These were the building blocks of the cosmos, created in a process known as Big Bang nucleosynthesis. Yet, it was still too hot for atoms to exist. For nearly 380,000 years, the universe remained an opaque fog, a glowing soup of charged particles. Photons, particles of light, were constantly scattered by free electrons. Light couldn't travel far. It couldn't escape. But eventually, the expansion brought the temperature low enough for electrons and protons to combine into neutral atoms. Suddenly, the fog cleared. Light broke free and began streaming across the universe. This moment, called recombination, gave rise to the cosmic microwave background, the oldest light we can see, a fossil glow from the dawn of transparency. The universe, for the first time, became visible, but it was not yet illuminated. What followed was an age of darkness, a cosmic midnight that lasted hundreds of millions of years. Though the universe was filled with matter, it had no stars, no galaxies, no light sources. Hydrogen atoms floated in the void, cooling further, gradually drawn together by gravity. The temperature fell to just a few tens of kelvins above absolute zero. The cosmos was quiet, still, waiting, but gravity was never idle. In the chaos of the Big Bang, minute fluctuations in density had formed, subtle ripples in the distribution of matter. Over time, these tiny overdensities became the seeds of structure. Gravity pulled more matter into the denser regions, amplifying the contrast. These ripples grew into clouds of gas, some stretching across light years. Slowly, they collapsed under their own weight. As they shrank, pressure and temperature in their cores began to rise. Deeper and deeper they collapsed, until one of them crossed a threshold. At its core, the atoms were crushed together so tightly that nuclear fusion ignited. And then, for the first time in the history of the universe, a star was born. The darkness was broken. That single point of light, isolated in a sea of nothingness, was the universe's first beacon. And it was only the beginning. All across the cosmos, in dense clouds that had collapsed in just the right way, more stars began to ignite. Light bloomed across the universe like sparks in a vast, cold forest. This epoch, the cosmic dawn, marked the beginning of a transformation that would shape everything to come. The stars of the cosmic dawn were not like the ones we see today. They were giants, population 3 stars, born from pure, primordial hydrogen and helium. With no heavier elements, no carbon, no oxygen, no dust, they formed differently. Their masses were enormous, many times greater than that of our Sun. Some may have reached up to 300 times the solar mass. Because of their size, they burned hot, millions of degrees in their cores, and lived fast, with lifespans as short as a few million years. That's a blink in cosmic time. They poured out intense ultraviolet light, heating and ionizing the surrounding gas, altering the very nature of space around them. But their true legacy came in death. When these massive stars reached the end of their fuel, their cores collapsed. Some exploded as supernovae, while others collapsed into the first black holes. In these final moments, heavier elements were forged: carbon, iron, magnesium, calcium. For the first time, the universe had the ingredients for planets, oceans, and life. These elements were flung into space, mixing with surrounding gas clouds. The next generation of stars would form from this enriched material, giving rise to smaller, more stable stars like our Sun, and with them, the possibility of planetary systems. Without the deaths of the first stars, there would be no Earth, no oceans, no air, no biology. We are, in every sense, made of the ashes of those ancient giants. As stars continued to form and die, they began to gather. Gravity pulled stars into groups. Groups merged into clusters. Clusters evolved into the first galaxies, messy, turbulent, irregular in shape. These early galaxies were small compared to the ones we see today, but they were fierce cradles of star formation. Over hundreds of millions of years, galaxies merged and grew. Stars organized into spirals and ellipticals. The vast architecture of the cosmos, the cosmic web, began to emerge, a massive network of filaments and voids stretching across the universe, held together by dark matter and gravity. And through it all, light continued to push the darkness away. As more stars formed, they flooded the universe with ultraviolet light. This radiation began to break apart the neutral hydrogen that still filled intergalactic space, ionizing it once again. Slowly, the fog that had cloaked the universe after recombination was lifted. This process, cosmic reionization, unfolded over hundreds of millions of years, gradually transforming the universe from opaque to transparent. The once shadowed cosmos became bright and clear. Light could travel freely. Structures could be seen. The age of darkness had ended. Today, we are beginning to glimpse this ancient epic. Thanks to modern space telescopes, Hubble, and more recently, the James Webb Space Telescope, we can now peer billions of light years into the past. Because light takes time to travel, every distant galaxy we see is also a vision of the universe as it once was. Webb has already captured galaxies that formed just 300 million years after the Big Bang. Ancient systems bursting with stars, emerging just after the cosmic dawn. And though we have not yet observed a population 3 star directly, the search continues. Their fingerprints may lie in the chemical compositions of ancient galaxies, or in the signatures of distant supernovae. Perhaps, somewhere in the vast archives of starlight, we'll find the first star. When we look up into the night sky, we see the end result of that first light. Every star we see, every galaxy, every spark of brightness, carries the legacy of the cosmic dawn. The universe is still expanding, still evolving. But the moment when the first stars ignited, when darkness gave way to brilliance, was the beginning of everything we know. Without those first stars, there would be no elements beyond hydrogen and helium. No rocky planets, no oceans, no biology, no us. We are, each of us, a story that began in the darkness, written in starlight, and carried across the ages by photons born in the hearts of ancient suns.